There we are. Again. Yeah, no music today. I'm listening to something else, which is probably not royalty free. Blah. I want to test this. Okay, now it goes wrong here on the pipeline number 1, I think. Just stop it again. And then somewhere in my history I have a grep. Probably looks like history. Well, I don't know. A grep inside this thing. Oops, nope. Well, I'm not sure if it is in this history. Let's try the other one as well. Yes, that's what I was looking for. Well, let's execute it in this terminal then. Oh, now I have troop here. Yeah, let's not run that here. Well, that's the same outcome. I did, however, forget what the position was for my window. That's so strange. Now I'm curious how it did store that. I think that is in Fluxbox ops. Name uniform buffers test and classes uniform buffers test. Why would either be different suddenly? It's in the corner here. Let me first try moving it again, closing it, and then running it again. Oh, I got a stupid delay. Yeah, now it remembers it again. Strange. Just gonna remove the clause. At least it doesn't change the values again. Okay, so now we run that thing. I need a history. Oh, just this. The one pipeline factory says realize the descriptor set layouts. The first one tries to create a uniform buffer with a binding of 0. Oh, there's something wrong with my chat. Let me see if we can connect. Okay, I think I'm in the chat. Test 1, 2. Let me know if that worked. So switch to live chat. Yeah, Demir is here again, and Shriyas Mali. Hello. You guys are super early. Super quick, I should say. And early. It's not even noon yet here. Right, so what happens? We create a descriptor set layout handle Yeah, hi. For the U0 here. And then we create a descriptor set layout handle with for the texture and the texture plus uniform buffer. Then it's going to create a pipeline layout from that. Where it puts well, hinting that it should use a set index 2 for, yeah, with the same handle as set index 0. And then the texture is put in set index number 1. And the other pipeline factory also calls realize descriptor set layout. And it also tries to create a uniform buffer layout, but it says, well, I found it in the cache because we created it here. So that's using the same handle. In the meantime, the first factory continues with creating the pipeline layout using ASCII. Use 0 because that was set index 0, followed by, sorry, that was set index 2, followed by U0 with set index 0, and then finally the texture with set index 1. That's at least consistent. C++. It's kind of in the title of the stream, C++ programming. Leaving logical device. Okay, this pipeline factory continues. It also found the next U0 in the cache, and it finds a T1 U0 in the cache. It continues with trying to realize a pipeline layout on its own. And also that is found in the cache. That's a good thing. This results in a translation from Z0 to Z1 because it wanted to have the texture a uniform buffer layout in set index 0, but the other one has it in set index 1. The binding is not changed, that is a good thing. Furthermore, it says set index 1 must become 2 and 2 must become 0. It's kind of funny because why? I'm using Vulkan.hpp, but I don't think it gives much benefit. I'm assuming you're not asking what C++ headers I use. I use all of them. Now this is kind of strange. Why would we want to translate 2 into 0? So 0 to 1, okay. Yeah, well, you have to do something. 1 has to go to something. That's true. Now they could have said 1 goes to 0 and then 2 goes to 2. And that seems pretty random. It's in the description, in the title even. I'm writing a Vulkan engine. Yes, it does. I have no idea why it's growing like this, but I'm just trying to be myself and do the same thing as I did, even though I think that's not interesting for viewers. Sorted bindings. Okay, why is it saying that it wants to translate 0 to 1? That was clear, because the texture with binding 1 and uniform buffer with binding 0 layout was hinted to go to set index 0. But what we found in the cache is it's about the pipeline, right? Pipeline layout. Okay, what does it say? Created pipeline layout. Yeah, this is totally random. Totally random. The pipeline layout uses twice the same handle for this and this. And one has set index hint 0 and the other has set index hint 2. But order is random. It might as well have been 0 here and 2 there. There is no difference. So why are the 0 and the 2 ordered part of the pipeline layout? And now this one. See, realize pipeline layout found in cache. It's not really telling us what it wants, or what, yeah, it does here. And that's the same order, I guess. So this one has the order set 1 followed by set 2. And this one has the order set 2 followed by set 0. Well, therefore 2 is mapped onto, well, the other way around. 1 is mapped to 2 for that reason. Yep. I have to think here, what does that mean? If you ask me, that means that the left and bottom will be swapped. It is always difficult for some reason. Yeah, right. Okay, and then this one calls create uniform buffers. Create. Update descriptor sets. Okay, yeah, this has to do with it, but my God, I have no idea how to approach this, but I have to verify my hypothesis as I described in the description of the stream by making the offsets the same, and then we'll probably see that I'm 99.99% certain of it, but let's test it anyway. So I have a left position. The offset here is, well, it's after a matrix 4. And the bottom one is after vector 2. So let's change one of them. Let's change this in matrix 4 as well. So now the offset of the float is the same in left and bottom. So if now we swap them, then I'm kind of interested in what happens. Maybe they will react to the wrong slider, but at least we should see values, I think. No. Well, maybe no, probably not. Nope. Oh, yeah, it does. It does. It does now. It's the wrong slider. So now left reacts to the bottom slider, and the bottom reacts to the left slider. Yeah. So just making the offset equal is definitely not helping. You really have to map them correctly. I might as well change this back. It's easier to see, I think. So make it back again. Back to. Well, the texture works. The T stands for texture. What did I do? There must be a comma here. No, this time it works. Yeah, I think it would be interesting to have a look at resulting shaders when it goes wrong. So this one goes wrong, and I think this is pipeline 0. So pipeline 0 will be wrong, but whatever. I still hate it that I don't see colors anymore when I edit this file. That used to work. Oh, here are colors. There's still some colors. And here too. Oh. I think that I know what it is then. I'm seeing the ASCII colors, but I'm not seeing the more advanced colors that I'm using. In order to see those, I would have to change Vim plugin. Hello, Zig 001. Right, so I want to have a look at all the compiling things. Compiling. So you see the left position is using the matrix 4. And the bottom position is using the vector 2. And we also see the set index numbers here. Left is at 0 and bottom is at 2. And that should of course be the same. That should definitely be the same. Okay, so a little problem. I'm not 100% sure. I'm only 99% sure that this was a run that was wrong. So this one is correct. I need the one that's wrong. Okay, so this is wrong. Come back to editor. Okay, so we have bottom is at set 1 now. I need a pen. So bottom is at 1 in this shader, and left is at at 2. Top is at 0 in this case. Yep. And here's another one. Top is again at 0, left is at 1. That is swapped. That, my friend, is swapped. So that would be the problem then. Bottom is at 2 here. And there's IMU stuff. This is the texture, which is texture is at 0. That's correct. So it should be the same set as the top. This is IMQ again. Again a texture at 0. I think we just jump to the top. Yep. Right, so I would say that the shader code is wrong, because this should have said set is 2 here and set is 0 here. Why would it be? Why does it have to be the same thing? Well, the main reason that I feel like it should be the same thing is because I'm using in where I'm drawing, so that would be draw frame, right? Or not. Here it is. So this is pipeline 0, and I'm using this vector here when binding descriptor sets. And this is pipeline number 1, and I'm using the exact same vector. And the order, this is a Vulkan handle vector of descriptor sets. So these contain the handles, VK descriptor set handles, ordered by set index. So at index 0 we have set index 0, and index 1 we have set index 1, etc. And therefore this vector maps each descriptor set to a given set index. And since I use the same vector in for both pipelines, that mapping is the same, right? However, you could argue that I should not have used the same vector. And now I'm suddenly leaning towards that is what is wrong, and this should not be the same vector. The reason I'm using the same vector here is because I only have one vector. But, well, I think we just saw it. Fix me, it doesn't belong here. God knows what I was thinking, but usually I'm right. So, I guess it doesn't belong here. Well, then where does it belong? I have a feeling that maybe it belongs in the pipeline object. In which case I would have two of them, one for each pipeline. And that is especially the case because it feels like that this block here is related to one pipeline, pipeline number 0. And I would like to replace this whole block with, say, a call to a member function of the pipeline object. So like, hey pipeline, do your thing. Yeah, well. And same thing here. So yeah, if this would be a part of this object, then this would make sense, I think. Because the pipeline contains, well, this is the handle. So, but at the moment that we created this handle, this pipeline, we were using a layout, pipeline layout, which included a bunch of descriptor set layouts in a certain order, even though the layout handles were the same. There's still a mapping going on, right? That mapping was being used everywhere. And well, yeah, you can kind of see that it's just has to be different. I'm struggling here. I mean, I don't want to make the mistake to you know, I can change it in two ways. Either I can change the shader code or I can change this vector. And I don't want to make the wrong decision here. What is the best thing? Maybe I can complete my drawing here, get the insight from that. Also still struggling to get this overview correct. No, the wrong decision is something that later you regret. And if the grid is big enough, then it's going to bite you. So in the most positive case, the best scenario, then you'll just have to go back and change it. So that would be a loss of time, a lot of time. And the worst case scenario is you end up with horrible code that is constantly buggy because something is just not fitting right. So this is not how it works. At the moment we make a pipeline layout, we already put it in some order, including the H1. So here I put the texture at index 0, but then you might think, yeah, well, texture 0, this always goes to 0. So here we have an example where it isn't the case. And I think that both cases are attempted. And it depends on the race condition which wins. But then the other one copies it. So what I can do is do a timeline vertically, going down increases the time. And I let this one win. So this mapping is being used. And you see that there is an ordering. One of the uniform buffers, even though it's the same handle, and that is the descriptor set, the descriptor allocation, that's why the A is here, is A0 and A2. But, okay, I have to copy this as well, man. That one loses as well, or is never done, I think. This is done afterwards, so I have to do... Okay, that's confusing. I think the allocation is done. I don't know when the allocation is done. Okay, anyway, this way it fits my story. So the allocation number 0 using handle 1. Handle 1 being the handle of the descriptors layout. This handle here for the U1, for the uniform buffer layout, single uniform buffer. And we have 2 of those, but I allocate 2. And I allocate also a descriptor set that uses the layout handle H0. And then my pipeline is using it in this order because Yeah, because there is also there is already an ordering here, right? So we have also here a set index. Now do that in your editor. Switch these two. Oops. No. Okay. ASCII. Put that thing here. And this has to be some other mysterious. I think I can remove the. Might as well remove it. I know. By now I know what that means. That doesn't really fit. This whole thing is just one pipeline layout. And then this one looked different. So I'm going to remove the arrows. Instead of the arrows, I'll use the handles, the H0 and H1. And we have here, I put this at place 0. And that would always be handle 0, the way I numbered it here. It's amazing how much a little ASCII drawing like this can help. I do it often and it gives you a lot of insight. If you do it correctly, it is. Oh, it's even different, I think. Yeah, these things are originally always ordered in a certain way, where the texture is at the bottom. And the indices are randomly. Well, not really random, but so I wrote it correctly, but maybe I should put this at the bottom. And here as well. Well, this one. The binding numbers are always the same. I'm also going to add those, I think. Which just, well, copied from the layout that you see here. Okay, Tefiken Inver. Show us what you got, man. I think this is yeah. You have to keep in mind that these three values here are more or less random. They're just hints. Now, if this pipeline layout wins in terms of the race condition in which factory creates the pipeline layout, it would create... I'm going to look at the source code, I think. Source code and debug output to get this image correct. If I have this image correct, I might understand how to fix it. And that was output was in the shader resource debug channel. Okay, so here it creates the descriptor set layout for uniform buffer binding 0. So that is this one. Well, here it's actually created. So this would then be H1 or H0 if you want to order it that way, but in my image here it's H1. And we not created more of them, because from then on it's found in the cache, so that is our H1. And here I have create a script set layout with a binding one that is a texture, so it's T1. And this is our H0 that is being created. So this is H0, which has a texture binding 1 and a uniform buffer with binding 0. Then it is calling realize descriptor set layouts, which is just going to hey, what? Oh, leaving. I wasn't right. Well, we just did that, yeah. Now we are going to realize the pipeline layout. And for that, it uses So U0 with set index hint of 1. So that is this. So the set index hint is just 1, don't ask me why, and that belongs to U0. And then it has the new line starts. So that is again a U0 with set index 2. That would be this one. Oops. And never give up. Never give up. The trick is don't have a deadline. I think I like quit only one project, which and I quit that because I realized that the only way I was able to do that is by getting a degree in mathematics, which would take me at least 4 years, hard study, and even then I just didn't feel like I had time. I didn't feel like I had 4 years time or more just to continue my project. But when it's something simple of just no mathematics, no higher mathematics involved, but just coding, then you just should keep pounding day after day, and you will make progress very slowly, exactly like I'm doing now. It takes very, very long, I have to admit. But the progress is there. I have to admit that I never have a problem with my motivation though. Okay, so this is apparently this matches pipeline 1 here, in terms of that we use uniform buffer 0 with set index 1. No, that will be this one. Yeah, this is U0 with set index 1 followed by another U0 with set index 2. I'm just going to put it here. I said 1 and then 2. Yep. 1 and then 2, and then t.1 u.0 with set index 0. So that is this one. And after that, scrolling down, after that we try okay, it's triple 2 that wins. Or not yet. Depends a little bit. No, it does not win. Oh yeah, it does win. It wins because it uses the identity mapping here. So this one wins. Yeah, does it really matter? I guess not. And on here, this is the thread pool 1 instead of 2, so that's the other factory. Realize descriptor sets, and that says I have no idea. I think there's a parenthesis, closing parenthesis missing here, but still, this is that's why I added the colors. Why am I not seeing colors? Because it's just hard to read. Every other line is a different thread. Yeah, hello there too. Great pipeline layout. Okay, yeah, well, anyway, the other one does the following. Uniform buffer 0 is at index 2. And that's the first one. So I'm going to put that on here. 2. And then we have a uniform buffer 0 with set index hint of 0. And the last one is then this, I guess. Yeah, T1, U0, set index 1. Yep. Right, and then one of them wins. Let's see if I can see which one. So thread pool 2 does say I created it. Yeah, at this point I really believe that that one did win. And the threadable one makes a mapping. I'm kind of surprised that I don't see debug output from threadable one saying that it found that it did find it in the cache. Let me look at the source code for that. So we see this line being printed, and then here we do the find, and if it then finds it in the cache, we come here, and indeed there's no output. Well, there is here at the bottom, found in cache. That prints it, but after that I stopped reading here and there's the found in the cache. Okay, so it is it finds the other one, and therefore it says I'm using this mapping. So we use this one, right? And the other one maps then 1, 2, 0. Yep, 1 is being mapped to 0. 2 is being mapped to 1. So 2 is being mapped to 1. So now it is this one that did win. Let's just add it here, I guess. So the pipeline layout that is being used in both cases is this. Which means that we allocate A0 is allocating using a layout H1, and A1 is using also H1, and H2 is using H0. And now I do not need this anymore because it just doesn't happen. So now I can reorder them. So I put a 0 at the top, which is using A2. Okay, there is certain order apparently in the allocation as well. Damn it, and I'll have to. I want to keep them corresponding to the actual what actually happens. Cannot find it back. So I was looking at realize descriptor set layouts. Okay, the calls in the order that they are stored in sorted descriptor set layouts. Realize a handle. It then calls realize descriptor set layouts. What? Right, so this would be it. That is done by threadpool 2, and that is the one that wins, so I guess that's okay. I expect it to be 3 of them. Yeah, here's another one. It allocates them in the order that they are in the sorted thing. So this is uniform buffer. And then we get another uniform buffer, and then we get texture plus uniform buffer. Okay, so it allocates them in this order. First this one, then this one, and then this one. So that is correct then. I'll just move this, I think, to a new line to highlight the fact that it is the same order. So yeah, and then we get 1 is being put in the middle, and that was the first one, which is A0. So this is A0, and number 2 comes from here, which is the second one, which is A1. And on the other side, the following happens. This one realizes that it lost, so well lost that there is already a pipeline layout that is the same, except for the set index hints. So it says, well, okay, we can use our idea, but I have to change my set indexes. So this side, this pipeline factory, says, I'll put it here on the same line as the wins, because this one loses. And it says 2 has to be changed into, well, that's also on this line. 2 has to be changed into 1, and 0 has to be changed into 2, and 1 has to be changed into 0. Just on the same line, this 1 becomes that 0, etc. Realize the script set layouts. I think where these numbers come from, vague, fuzzy, but still, it's more or less, well, this is for certain the top, right? So I can ask here, put top, use textures in the top layout thing. And then this is left, because it is linked to set index hint 1. And this is bottom. That is the intention. And the reason for that is that I create these things in that order: top, left, bottom, and there I get 0, 1, 2. That they are ordered then in this order is also pretty random, and it's just because t plus u is larger than u alone. It's just some kind of ordering, which make it easier to compare the layouts. You have to use some order. And here I swapped top and left deliberately. So 0 and 1 got swapped. And the 2 is still the bottom. This is the intention. This is what the pipeline is trying to do. And now it depends on the race condition which one wins. If this one wins, then the top is put in 0, and if this one wins, then the top is put in 1. But also the left and bottom, well, the bottom is always in 2, and the left is then moved off code. So left and top are switched. And now you see something horrible happening here. For some mysterious reason, it maps pretty randomly 2 to 1. In other words, it puts the bottom in 1. And it puts 0 in 2. It means it puts left in bottom. So it swaps left and bottom here. This is correct. So top goes to top. So 1 goes to 0. But this is nonsense. Yeah, hello, Mr. AA, Gaia SWAT. And Mr. Company, I'm making a Vulkan engine that automatically generates the shader declarations and set and binding numbers. Yeah, well, it's pretty clear actually. The swapping of left and bottom occurs because in this one it is left bottom top, and in this one it is bottom left top. So bottom and left are switched. Right, so something is horribly nonsense here, because why the hell would that happen? It's pretty random. Even the top stage itself is random. It's only happening because there is only one layout with a texture and a uniform buffer in it. So that kind of forces it on top of itself. But if I would have a fourth corner that also has a texture and a uniform buffer in it, then those would also be randomly mapped. But yeah, not all is lost. I think that I called it fuzzy, and that's what it is. So we'll just have to swap bottom and left again at some point. And just let go of that this is left is linked to 0 and bottom is linked to 2, because that's not the case anymore. But how do I find that out? And I can swap them because they have the same layout. they are compatible. And that compatibility is exactly why this swap was even possible. So I think I have to look at the point where I'm linking bottom and left to well, the actual allocations. That is A0, A1 and A2. And that happens at the moment we call update. And that is only done once. And I'm not even sure by which thread, which makes it double fun. I think there's only one thread that does it. And that can be also either, well, factory. I think either factory can do this, make this link. And that's probably why it swaps left and right. Or, I don't know, maybe there's two race conditions. It has to be. I think that every race condition only has a single swap. Yeah, also race condition between two factories. So either there's two possibilities. Either one is faster or the other is faster. So we have two possibilities and we have three outcomes. Maybe you have four outcomes, but then two are the same. So we need two race conditions to get at least to get three different outcomes. So yeah, I think there's might be another race condition for who gets to call the create uniform buffers. And that then links this arrow here. And we have to look at how that order comes to be, right? Can't wait till this is finished. I'm getting really tired of it. Okay, back to the code. Do I need my debugger output still? Maybe. So I think we did all of this now. And this block is also okay, but I want to understand these errors here. And now I'm kind of updated this image. So I'm just going to do this to do now, I guess. You have to agree that that my drawing here is a lot easier to understand, in terms of overview at least, than this debug output. It is hardly readable. So the information is here, but really you have to digest it first. Entering realize pipeline layout, we did that. Create pipeline layout, realize pipeline layout, found in cache, leaving realized pipeline layout. There we are, one of the thread pools, and apparently that's thread pool 1 here, calls create uniform buffers. And there's a horrible hack to begin with that detects that the binding that is being used for the texture is 1. I'll fix that later, I guess. At least it's correct. And then we allocate the descriptor set. Allocate descriptor sets 23, 22, 22. In that case, I didn't make a mistake, I think, because I thought this order is the real set index. So let's have a look at the code. As if I have nothing else to do. Stupid spam bots. Is C++ good for DSA? I don't know what DSA is. What is DSA? This? There's a lot of DSAs here. Data structures and algorithms. It's a bit vague, but yeah. It would be good for this, I think. Okay, the spam bots are gone. Let's look where this is being called. Probably from here, apparently. But yeah, this is ordered by real set index. It's being passed like that to the create uniform buffers. Still a bit weird though, you know. Here I use the standard call once, So only one thread, and then it completely depends on who is first, gets to call this. And it then passes this vector. And it got this vector from here. Using the translation map. Well, that's definitely vague, to say the least. So what that does, it runs over the unsorted descriptor set layouts and then puts the set using the converted set index as an index for that vector to put the handles into. So let's construct this vector for both pipeline factories, because we don't know yet which wins, right? And these are the A's. It's the descriptor set layout handles are really the allocation. I think. Now I need another tab. I'm just going to need another tab. New tab. And then nothing happens. What the fuck, dude? You hear me click, right? Why do I not get a new tab? Oh, I have to choose. CD projects AICXX Linux viewer source tests, I don't know, uniform buffers. And let's put the readme here. Yeah, that happens before this. Well, although depends on who's first, right? So let's say this factory here is first. Now it's suddenly a factory, but okay. One factory tries to create this pipeline layout, and the other factory tries to create this pipeline layout. So I might as well call them the factories. If this factory that did win the race for the creation of the pipeline layout also wins the race for who is creating the uniform buffers, and then the following happens. It creates this vector here using translated set indexes, but there is no translation because we have an identity for this map. And then copying the handles from the descriptor set layouts. What is that? What does that mean? Uh, 28 years C++. I think this means that we go this is the M sorted thing. So this thing here is basically this, in this order. That I put it in this order is the sorted part. So we run from top to bottom over this thing here. Then we get a handle. And that confuses me a little bit because I did not write a handle down here, but because this one wins, it did allocate something. So that's probably the A0, A1 and A2 then, in that order. And that is put in whatever set index is being used. In that order in the descriptor layouts thing. So this becomes okay, so first it reads A0 and it puts it in 1. And then it reads the second one, which is number 2. So it puts the second one, which is A1, in number 2. And it puts the last one in number 0. And the last one being A2. A2. Which, by the way, is exactly this order that we have here. Yeah, okay. Now we continue, because we are now inside the function well, this happens outside the function, but then it's a local, it's copied, the result of this thing is copied to a local vector. To go here. Nope, you have to go Control T. So this, we were just here, and what it returns is put in this local vector. And then that local vector is simply discarded, or it is, or it wins the race here of the once flag and the call once, and it is passed to this function as the second last argument. And we were assuming that it would win. So I go to this function now. And now there is only one thread that executes this, and we're going to assume that is at pipeline, first pipeline factory 0 also. And then it does the following thing. I get the key from the top buffer, which is translated to the set index hint, which is then converted to the real set index. So I think the top descriptor set index becomes zero. That should go right? Yeah, the set index hint that we get back here is simply what we initially offered. So that should be 1, and convert is identity, so we get back 1. So that no doubt is that like that. And now it allocates the descriptor sets. Oh, that happens here. Already put that here, but that's not true. That is not true. My music stopped. Okay. What to do? What to do? Okay, that's just ordered by real set index. And I guess it doesn't really matter how I'm gonna use A0 then for the allocation belonging to set index 0, etc. Okay, this vector becomes A0, A1, A2. And it is using the VHV realized descriptor set layouts as layout. Which I used the A2, A0 and A1 for. What? Yeah, this is done before we call create uniform buffers. Although might as well, yeah, put it in front of it. This cannot contain the allocation handles, and it isn't. It's just containing the H handles, right? In the order of 0, 1, 2, so we could just get H0 here. And then H1 here and H1 here. And I'm going to explicitly add this in front of it because that it's being ordered by set index. Con type. And then here we get something like the same thing, but slightly different. That's this one. And this then, per definition, contains A0, A1, and A2. But we have to realize that they are using the layouts that we had in that vector above. Okay, the buffers are created, and then we get to the interesting part. update of the descriptor set, which links the top buffer first and then the left buffer and then the bottom buffer to the descriptor set indicated by the top descriptor set index. So we have MVHV descriptor sets. That's this. And we use the top descriptor set as an index, and that is linked to the top buffer. Okay. But now I forgot it again. Top. Okay. Top descriptor set is 0. Used in this thing here. That is in this thing here. So that is A0. Is being linked to the top. So this is really A0. Yep, and this is A1. And this is A2 by definition. Now this is really top. Here's this T here is literally top. That there's a texture also, who cares? And that is linked to A0. Why is it linked to A0? Because the top is 0 and 0 contains A0. And the left is 1 and 1 contains A1, so left is linked to A1, etc. Right, so that's that, and that is easy. And now the other one. Because either this one wins the race of calling uniform buffers, or the other one wins. Now, what does that look like? So we get again this. So we go to the top again. Now the set index that is being returned is the one that belongs to the top, which is this one, so 1. And that then gets converted. 1 gets converted to 0. So top descriptor set index becomes 0. Shall I add that happens? Okay. And then the left descriptor set becomes, well, left was 0 and is translated to 2. So that is 0 translated to 2. And then the bottom one becomes 1, obviously, because the bottom was 2 and 2 is translated to 1. And then this was per definition this order, and also the A1, A0, 1 and 2 are in this order. But what about these handles? Well, that doesn't change, but let's have a look at exactly how it was constructed. Yeah, about beginning and advanced. This is, I guess, difficulty exists at two levels. One is, of course, the syntax. So if you look at the code, do you understand what the code means? Not what it does, but what it means. Like if you look at this and you see standard pairs less than shader, what? Then you don't understand the syntax, because these angle brackets here mean beginning and end of a list of template types. And if you don't understand what this colon is doing here, now you don't know the syntax, because that means that we have a variable here of the standard pair that is in front of it, is type, that runs over all the elements of the STL container bindings. So that would be the syntax. But on top of that, and that is what I'm wrestling with, is that the program itself is difficult as well. Now I'm out of it. I was going to find out what handles are here and how they came to be. And that is where we call allocate descriptor sets here. And they are created from the VHV realized descriptor set layouts. Right, I have to fill that in first. Okay, how did this work again? We were running over this in the order top to bottom, and then filling in the handles that we see at the translated, the converted set index hints. So 2 is translated to 1, and then we fill in 1 with handle 1. And then 0 is translated to 2, so we fill in 2 with handle 1. And finally, 1 is translated to 0, so we fill in 0 with handle 0. I don't think it's really a surprise that they are the same. That's a good thing. Even though in this case it did go through the translation of the set indexes. And that means that this one is filled in the same order. So also here H0, H1, H1. So also the A's remain in the same order. And then we get to the interesting part again. The call to the link. Okay, so how does this work? This links the top buffer to MVHV descriptor sets top descriptor set index. Top descriptor index set is 0. And that is filled into the in this one, so we link it to A0. And I think that also here this is just in this order always. A0, and A0 is also per definition A0 is handle 0, and handle 0 is this. Well, this. So that is just informative. And then we link it to the top, which is written like this. And that is correct. And now, please let it go wrong here. Otherwise I did everything for nothing. Or at least I really don't understand that anymore then. So the next step is we link the left to left descriptor set index. It's number 2 of this list, that is A2. And A2 is H1 and H1 is U0. Yeah, that is correct, but that's not necessarily hashtag 1. Why is it in this order? Okay, now I'm confused again. I think A2 goes in, always go to, yeah, A2 is just linked to hashtag 2. So this goes into 2. But why? I think this is correct. Let me type it in because then I have that, but I'm not sure really. Oh, wait. Okay, I messed up. This is exactly the crucial part of it. Grr. Why is there a hashtag 2 here? A hash 2. Why is this not in order? The 2 matches this 2. Okay. Why? Ugh. Left descriptor set index is 1. I have to look it up. There is A1. Okay. And A1 is in hashtag 1, I think. Should I turn them around, and then left is linked to A1, which is then happens to be set index 1. And in this case, left is linked to bloop. Yeah, left is 2. There's no way around it. So I want this to be in this order, and then that is also automatically in that order, and this is just swapped. Right, so depending on who wins the race to create uniform buffers, left is linked to set index 1 or left is linked to set index 2 and bottom to the other one. I wonder if I have enough information now to go for a walk and think about it while I'm walking in the forest. But I don't feel like very certain about it. It is difficult. Why does this go wrong? No, I don't know Python. Well, I was deeply concentrated. The question is super recurring. I've been coding C++ 28 years now. But I have to think about this, or at least I have to think about it until I feel that I don't have to look at the monitor anymore. I have a feeling. But it is so vague, I cannot even put my finger on it yet. There is an arbitrariness somewhere. But why? Yeah, of course. The arbitrariness is in the sorting of this map or set. What is it? Map, I think. These two, they compare equal. So it completely depends on the input how they are sorted. So there is absolutely nothing that we can know about the order of the first two elements, both on this side and on that side. Now, if this side wins, then, well, and it did, so it's just whatever it is we use, 1 and 2. But this side has a problem, because 0 and 2 are completely random. And then after mapping, because the mapping becomes random. This 0 and 2 are random, therefore the mapping is to 1, 2 or 2, 0, 1, 2 or 2, 1. Which means that 1 and 2 are just completely randomly chosen here. 1 and 2. So you get UB or UB UL, or you get UL UB, depending on the sorting of a map where the key is the same. Do you understand what I mean? Yeah, so the cause of the arbitrariness is crystal clear now. But then the next question is, right, that same arbitrariness happens on this side. I said it's just being used as it is, and that's fine, but it is still arbitrary. So we don't know which is which. It can be 2, 1 or 1, 2, we don't know. And then we always have the identity. And here we have, here it doesn't matter, because if you swap 1 and 2, that doesn't matter because it's both the same handle. But here it swaps also left and bottom. 1 and 2 are swapped, left and bottom are swapped. Here again it doesn't matter. And here again left and bottom are swapped. So by picking this one, which has a random order, and then linking it, we make a choice. And that choice has to be propagated to the other side. And that propagation does not exist at the moment. For example, and I'm not sure about that, but I could, for example, store the set index 1 inside this object, the left uniform buffer, because that is the link that I make. Probably better I just link it to A1. And then here I can overrule it. I'm just saying, sorry, but I already know that left is linked to A1. In fact, I already know that top is linked to A0. I don't even need to use this mapping. The mapping is wrong because the mapping is incomplete. I need to use a different mapping, and the mapping comes from here. Now the A0, A1 and A2 are always in the same order, so this also has to be in the same order. Yeah, well, no, not really. What I get is a second mapping. This is what I would do, this side, but I'm not doing it. But if I realize that I would do it, I see that now A2 is linked to L, and L should have been linked to A1. So we have I could deduce a second mapping that swaps 1 and 2. And then I have to do that, change the mapping here, and swap 1 and 2. So then 1 goes to 0, and then 0 goes to 1, and 2 stays at 2. And that's exactly what I want. Yes. Okay, problem. I don't know that. When I am compiling my shaders, well, actually I am. Yeah. So here I'm compiling my shaders, and by that time the set binding map must be fixed. But the exact binding map depends on who wins this race. So what I should do is first decide which thread wins the race, and then the other one must see that it lost that race, and then it has to change its map, and then compile the shaders. And then after I compile the shaders, I can actually call this function, I think, or is that not necessary? No, it's just uniform buffers. I think I can move this to the top. I think I can move this to the top. I don't think this depends on the compiling of the shaders. Yeah, let me try that. If I move this down, then I think nothing changed. Nothing is changing. Except that now this block of code can correct a map before I compile the shaders. Well, come on. The race is pretty much the same. Okay, now the left one is broken, and we have a lot of that it works. I want to see the right one being broken as well, just once. Yeah, okay. So I don't think anything changed. So that I can use it. Yeah. Wrong line number, of course. I had to open it with the wrong line number. Create build shader. That is here. Okay, now I could just go on now, of course, and try to fix it, but I have to eat anyway, and it is nice weather, so I am going for a walk. And at least I have something to think about now. Otherwise, walking is so boring. So I'll be back later, okay? Stopping the stream. The sun wasn't... Sun is always shining on my monitor around this time of day also. Can hardly see the button to stop the stream. Oops. Okay, I'll be back in I don't know. Really, sorry, man. Maybe 2 hours. I don't know.